Hello, everyone. Welcome to our webinar on the value of AI for part reuse and standardization. Happy to have you. Looks like we have a lot of attendees, so we're excited that you all joined us today. Rob, you want to go to the intro slide maybe, and then I'll just do a couple of quick introductions before we get into this. We have a lot of content to show you today. So I'm James Carr, application engineer with GoEngineer. Been working mostly in data management and product lifecycle management for over 20 years. Experience with some of the products you'll see today, as well as various PDM and PLM solutions. And I've kind of been involved in consulting and pre-sales and services and kind of everything all around. And I'm joined today by Rob Doneth. He's a senior industry process consultant with Dassault Systems. He has over 30 years of experience in a lot of different areas of kind of around software, manufacturing, consulting, and he's been with the NETVIBES brand of Dassault, which is what we're going to look at today, since 2012. So Rob, I'll pass it to you. If there's anything else you want to add to your intro, feel free, but go ahead and take it away.
Okay. Thanks, James. Yeah, hi, everyone. I'll just keep going from here. I think you're going to be more interested in the content that we're going to provide than this. So what I'd like to talk about today to start with is what we call information intelligence. And, for me, I've been married for 30 plus years, 30, almost 40. But I do a lot of traveling, and, sometimes I want to take the wife out for a restaurant, but I might want to find some flowers nearby. And, the old days of trying to process through data, you'd have a bunch of spreadsheets, and you'd use the spreadsheets to try and figure out what matches against the, one set of files like ERP to PLM or CAD or whatever. And this is the way that normally a lot of organizations would try and limit their results. But nowadays, you have the ability to bring up really good real life example tools that show me, oh, here's restaurants in the general area. I'm going to look for flower shops that are close by in the same general area. And then overlapping these two views allows me to find a flower shop that's really close to the restaurant where I'm going to meet my wife as we get off of our work cycles to meet up. So she could be a little bit more surprised. And what we do from information intelligence is that we aggregate data from multiple systems across your organization, basically creating a single view of the truth. On top of that data, we can provide search and analytics, which keeps all the relevant data real time, right away in front of you to help make fast and easy decision-making processes. And you'll see examples through some of the other videos and demonstrations that we do how we can use this information to collaborate in rich contextual modes to everyone in the organization who might have stake against that data, whether it's CAD in the engineering or manufacturing side, or ERP through supply chain, or aftermarket with warranty and services, et cetera. So how we do this is that we have connectivity into the various source systems. So both structured data like databases and IoT related data, XML, you probably have PLM and CRM, ERP, MRP, all kinds of different systems. But we can also take unstructured data. You might think of CAD as a structure because it's a physical structure, but the actual CAD file doesn't have a lot of structure in it that you can recognize or pull out from. Unstructured data like PDFs, so Word documents, the textual information where it's difficult to extract out sort of attribute or metadata or parametric information from that document. We bring all of that into a central location from an indexing standpoint. We utilize AI and machine learning tools along with the context to provide some semantic processing. And the end result is that we have this connectivity result that allows you to do things like enterprise search. What we call actionable analytics, where I can drill down to, this particular change action, it hasn't been approved yet, but that's because this person's on vacation this week. And if I have authoring rights, I can go and, impact that change. I can go back directly with a single click from the dashboard view to make the change, to add, have someone else actually become the approver for that so that we can get that one change request on track. As I mentioned, coexistence model, when we index your content, your content stays exactly where it is with all the business processes. and security rights and everything else that you have there. And in the process of sort of ingesting or indexing that information, we can also pick up the security such that when somebody goes to search for information into the system, if they don't have access to see it in the original source, you can hide that result automatically through the system from them seeing even through the search application. But it is not replicating the data. It's providing a link back to where the data is and representing the access rights to the users as they make their decisions. There is a Q&A section, by the way, I wanted to mention. So if you have a question as we go through here, please post it up. And either James or myself will try and address it as we go. Or at the end, we'll cover all the Q&A if there's a lot of questions that come through. Okay. So first off, we're going to do things like index the data. We need to get the data into the system. So we do that through indexing this information. And the key portion of it is actually sort of breaking out your silos, right? Aggregating the information from all these different places. Technical characteristics coming from the CAD, 2D drawings, 3D drawings, maybe coming from the PLM, pulling in supplier information from your ERP data, perhaps business attributes that might be defined in the ERP or even manufacturing areas, ingesting even things like purchase orders. So I can see if I'm doing like a build to order design, perhaps the lead time from the ERP system versus the lead time for another component that I could select. So I could select one that'll get here sooner because we may not have an inventory at this time, but we need to deliver the product at a certain time frame. On top of that, we also can grab the geometrical features from the product, your CAD models. So analyzing, the 3D geometry of it, identifying things like the number of holes, the type of holes or the shape of the holes, the depth of the hole, etc. And working out through all of this an AI-powered sort of component signature that allows us to then map or automatically define and see that when I select a given component, it will suggest other components that are very similar in shape and size that I could potentially reuse instead. So I'm going to turn this over to James. He'd like to run a little poll real quick with you.
Yeah, thanks, Rob. Okay, yeah, so I will publish, that was the CAD, was that the CAD types or CAD files located, right, Rob?
Yeah, CAD files.
CAD files located, okay. All right, so yeah, there's a polls tab you should see, or a pane where you can go and answer the poll question. So let's take a few seconds to do that. I'll wait for some of the answers to come through.
And you might also mention that there's these are multi-select, so they can select multiple. So all of the polls will select for today.
Yeah, thanks, Rob. Yeah, good point. Right, still seeing a few come in, so we'll wait just a couple more seconds here. So yeah, it looks like we're mostly, the majority, we're seeing some SolidWorks PDM storage. That's great. We have a connector for that, so we'll talk more about that. Shared file systems, pretty common. That's what we're used to seeing, which can be various network shares in different locations. We have some Inovia and 3DX sources and some other PLM systems as well, which there are connectors for those as well. So all the things you see today that Rob shows and those benefits are available really for data in all of these sources. So I think that should be good. Yeah, I'll go ahead and close out this poll. Thanks everyone for participating in that.
And I will go ahead and
so you can
reshare my screen.
Sounds good.
Thank you. And thanks for everyone's feedback. Appreciate you getting involved here because we're always interested to know what people's environments look like. So now I'm going to kind of break into a short demo. You remember that first point, which was break the silos, being able to ingest and understand your data. We have something that's called the Edge Agent. Today, we're going to be showing you a product called Parts Supply. Let me bring up my actual demo environment. I can find my right screen here. It's inevitable. Where did it go? Here we go. I had it up. All right, thank you. So Part Supply Enterprise is an environment that actually provides for a multitude of parts. There's about 46 million components here that you can actually log into or go to this URL, this Part Supply Marketplace, and explore the catalogs and look at the data inside of this environment. If you're interested in also storing your own company's data, specifically tied off or secured out to just your environment, you'd purchase this application stack for your company, and it would provide for a company ecosystem. And if I bring up the tools section of this as my user account, this is the Edge Agent technology, where they would be able to download what we call the Edge Agent. You would configure this to run inside of your environment on premise, and then use it to connect to both PDM web service through a web service to your PDM Pro environments. It also has a file system connectivity. And later I'll be showing you how once you configure this and then you start to ingest your data, it promotes that up into the environment and makes those catalogs similar to the catalogs that are in the community area available for your internal users only to be able to see. Okay. Any questions on this so far? Okay. So kind of go the other way. All right, so here we're going to want to search against the content. So I'm going to look for maybe a part that supports my electric engine. I may then have to do some semantic search to browse through or find other attributes. And this context search will show a couple of different videos. This would be actually running inside of the 3D Experience platform, where I'm doing a CATIA design and then doing a search against the data sets that exist in the system. And then actually have the ability to, here, I'll bring it up so you can see. So I have a rough of this component. Here they're going to use our one part, our on-prem version, I believe, in this particular video, but this works the same way. If I actually slow this down here, I'll snap it back. Right here, you see where it says one part search. Just below that, they could be searching inside a part supply if they were using the part supply environment for their CAD models here. And then they'd see similar types of results. I'll show you what that looks like in the part supply a little bit instead. And it's actually using the physical geometry of this rough idea to find other components that have holes in the same general direction, are of dimensionally the same location, and the same size as the given base bracket that was designed to maybe help reduce weight in this particular case. And you'll note that as the user selected this given component part, go back a little bit, in that design, with a single click, sorry, I'm just going to reduce it back down here. With a single click where the mouse is right now, this is going to replace the part in mate position. So with a single click, it will actually put that given component part in mate position, give you an idea within your actual design how it would work. This works with both CATIA V5. It will work in conjunction to SolidWorks design as you're running through, if you're using SolidWorks internally, etc. And here you can see where I can find other similar parts around it and other specific information around those. So I can compare options around how close are they in geometry, see side-by-side comparisons, etc. All of that kind of functionality that you see here is also available through the marketplace, part supply marketplace. In this particular video, was showing it inside of our on-premise environment, one part. So as you can see, when we ingest the data, when we're doing a search for a given component part, we get semantically linking this information where I select or can filter on various information, part type, materials, supplier related information, anything that could come from your data sets, and then see if I select a given component part. In this case, I'm showing the similarity that you saw from before inside of the one part UI, but this is the marketplace UI, part supply. and looking in context where it automatically identifies similar parts and allows you to then see how they compare and what they look like. And I'll do a really short demonstration of searching for a given component part here. Go to my catalogs, and you'll see here that from an organizational standpoint, I have these catalogs which are specific to my company's ecosystem. Here I'm by default not allowing the users to look inside of the community marketplace. However, if I click here and I look in the marketplace, I'll find similar parts in there as well. Here I'm just going to search for like a bracket. You can see reasonably quickly how fast it comes back. I'll select a given component bracket right here. I might see similarity based off of this bracket. Where used, in this case, it's part of this assembly. So I have both the bracket and where it's used, so the impact of it. And if this one had been a bracket that we were going to be removing from the system, I would know exactly which parent had that bracket in it. And then I could, see the relationships of all the other parts that are part of that assembly as well. So if there was one of these components that we needed to remove from our inventory, to remove from the supply chain, I could then go and use it to then search for something similar in the system that I might be able to replace. Okay. Once again, if you have any questions as I go through this, please feel free to put them in the chat or the question and answer. So here, we've done this part search, and I wanted to give you some examples of, how in different industries we see various, engineering to supply chain rationalization or cross division environments. I have a little video here I'd like to present from someone from Eaton.
Certainly one of the most powerful features we've brought in later in our lifetime with Dassault PLM has been the Exelead search module and the immediate impact that had on our engineers using it. Even a week after deployment, we were getting praise from some of our custom order engineering that we're finding parts and able to reuse parts that we would never have been able to find previously. And that's a solution that, I wish we could have had that 10 years ago.
Thank you. So I'd like to talk about an example. This is actually a customer of mine that I worked with a few years ago. They had over 100 different industrial divisions, primarily running with Inventor Vault, but they also had Innovate, 2012 or 2013X, where their aerospace divisions were working. And we deployed the application for them, and we ran an end user sort of adoption day, about an hour's worth of initial training to kind of go through, can you log into the system? Here's how you kind of search for information. Here's how you could take a CAD model, draw a CAD model file and upload it into the system to actually have it look for something similar in shape and size. And on the second day, we kind of kicked off a more advanced search with just a review of all the users that we did the initial training with. Did you use it the day before? Did you have any activity or issues that you had trying to find something so that maybe we could do some searches to try and locate that or fine tune that as part of our advanced search? Or were you successful? Did you find, something that was really cool that you want to talk about? And the first user, his name was Steve. To this day, I still remember. He said, well, he was looking for a certain kind of fitting that had certain dimensions. He couldn't do like looking at typing in text to try and find exactly what he wanted. Based on what he saw from the measurements, it didn't actually match up to what he needed. But he remembered that drawing or dragging of the part file in. So he did a quick mock-up of the part with features he needed. He uploaded it to the search window, and within seconds, he actually found exactly what he needed and could just reuse that part in his design. It was already sourced. They already knew that they could get their hands on it, et cetera. And we asked him at that point, I said, what did you do before you had this tool? And he said he normally would take about an hour to try and find something, looking through MRP and ERP data if he didn't already know a part number that might exist for it. In this case, it took him 3 minutes to mock up this part design, and he got an answer in seconds. And overall, the very first time he used the product, it actually saved him about 55 minutes of his time, he estimated. So if you think about in the design aspect, and this is external research information from Gartner Group and Arthur D. Little, Aberdeen and Arthur D. Little, that 45% of the time an engineer takes is either recreating a part or searching for a part. And I'm not sure how many engineers actually understand that every time they recreate a part that's already been created, it actually puts between $4,000 and $23,000 per new part, because of all the costs, downstream costs that are impacted when a part gets introduced into the system, whether it's certification on the part, sourcing of the part, inventory of the part, etc. So if you can get a 20 to 40% improvement in how much time you spend looking for a part, one, that will help you, because as an engineer or a designer, you'll be able to spend more time actually creating designs that are worthwhile and valuable for the organization, instead of creating a design that is actually costing the organization even more money because they already have a part or component in stock for that same activity. Of course, once again, here, we indexed content, and you can use the analytics around this to do like a search of every part that was at Rev 1 that was created between, during the calendar year for the year before. And they found that there was about 64,000 parts in their system that had been created the year before that were still at Rev 1 or Rev A or Rev 0. And half a year after they started using this tool across the board, extrapolating the new parts that got added would have come out to about 40,000. So that's a reduction of 24,000 new parts that didn't get created during that, or wouldn't be created by the end of the second year, which is probably closer to 30% reduction in their particular case. Once again, the cost of this is pretty clear to the organization. So being able to ingest the data, understand the data, be able to search against that information is a starting point. Now, what can you take advantage of? And here's where we talk about using some AI tools to classify and standardize and help clean up your data, especially organizations that are looking to potentially migrate into a new system, or expand, into something more structured, or do some transformational activities internally, but are also looking for cost savings, right? With tariffs and all kinds of things, there's a lot of added costs that are happening in a lot of organizations, and they're constantly looking for new parts or ways to save in their supply chain, especially. So we enrich the data through this 3D analysis, using 3D shape as sort of the universal language, creating sort of a shape signature, as it were, although we represent it here with these little fingerprints. But being able to use an AI-driven similarity classification or identification to group parts by family or class, by clustering these together, we can quickly identify parts that are quite similar and group them together so that you can then define a standard or an alternate or not for use scenario, and help then promote that information back into engineering, so that when they go to search for a component and they have 6 different options, they'll be driven toward using the preferred or the alternate, and they'll stop reusing a part that's no longer for use because you're trying to remove it from inventory and take advantage of the standardized component part. So I'm going to pause again here. If you can run the next CAD poll, which is CAD types, not TED poll, but CAD poll.
Yep, I got it here. CAD types. Yeah, so we'll do the same thing. I'm opening the poll now, and I'll share the results of that as well. So yeah, you'll see that in the same poll panel. So if we can take a few seconds to answer what CAD types you're currently using. And remember, it is a multi-select, so feel free to select as many as you have. Yeah, we'll give a few more seconds to get some entries in. Looks like probably as we probably would have expected, I guess, or as I would have expected, mostly SolidWorks, but a good mix with CATIA and some CATIA 3DX as well. Good amount of AutoCAD, some Inventor, a couple others. Yeah. And I still see a few votes coming in, just a couple more seconds, and then we can close this one out. So yeah, pretty good mix here of CAD systems, which I believe are all supported by this indexing and the stuff Rob is showing. Okay, so yeah, we'll close this one up here, and then I'll pass it back to you, Rob. And remember to share with I think you have another video, so
yeah,
share that audio when you share your screen.
I appreciate that. Thank you.
Just a reminder, friendly reminder.
Yeah, a little bit easier this way. Okay, well, thank you, everyone. Yes, as James mentioned, we support these CAD models. We're very CAD agnostic in this particular case. If there's additional CAD tools that you're using, we'd be interested in determining whether we could or have support for those as well. I just grabbed a few of the sort of major ones that we support out of the box with the application at this moment. So thank you for your input. So here we're going to take a look at, the sourcing and standardization of savings. How do we actually run through this clustering environment, looking at the semantic shape and the other data, identifying these duplicates to define the alternative parts, etc. So I'd like to run through a part standardization. Now here you see something, I'm showing a screen because I'm not actually going to create a universe to do this, but I'm going to look at, give it a universe name. How are we going to determine what we're looking for here? We're trying to develop or determine standards against all of our parts across all our divisions and product lines. I have my universe scope, which is the both in-house catalogs. Now these would be catalogs that are coming through the Edge agent into Part Supply Enterprise. But if at the same time you're starting to utilize the 3D Experience platform on cloud, the collaborative spaces that exist inside of the cloud infrastructure can be brought in as well as those catalogs. So you can see here where I'm going to look at across the board all of my environments, both the public cloud and my on-prem data sets. And then we're going to see how it creates these sort of clusters, and the size of these clusters are based on the number of components that are in that area. So I'd like to bring up a little demonstration again. I can scroll through all my windows and find the right one. Okay, so here I'm going to look at the standardization in intelligence area. And I've got my current parts. This is the cluster that I had. If I go back here, I can see that I've created a few clusters here. All right, I've got several parts or clusters, and I want to actually explore my clusters. So you'll see I've got this cluster here, and I'm going to go to this one. And I will just select this given component cluster, and you'll notice that these brackets all are very similar in shape and size, the dimensional view here, but several of them have slightly different holes, and that's because when I clustered it, I asked it to look at plus or minus 10% in variance from the shape signature. You can narrow that down to like nearly 0 or absolutely identical. But you'll see here where I've got this one set as a standard. So if I actually select this, you'd see that this would be either remove or add a standard tag. This is my preferred tag. This one is actually set up as an alternate. So here it would be grouped as an alternate part. This one actually is selected as a not for use tag. This enables me to then say out of this cluster of 19 parts, I have 10 that could be alternates, 6 that are preferred, and that there are 9 which we're trying to remove out of potential inventory and tracking from the MRP and the ERP systems, etc. I'll just go back and look at another couple of clusters here. I think this one's a pretty good one here. You can see that I've validated or I set these up as either standards or not. I could select that, this one I want to actually make this as a standard. So here I'm just going to group it and then add the preferred tag. I link it. There we go. So here I'm going to create and flag this one as a standard. Perhaps I'll select this one also as a standard. Because maybe the material is different or something along that line. So I'll select this one as a standard, and here I'm just going to select this other one right here and add the not for use tag. At this point now, I could then validate this, so it would then notify someone else, perhaps in a work process flow, that they would need to validate that these are correct and they feel comfortable with this based on the information that's available. And then they could then publish this information, which would publish that cluster information to the reuse area of part supply as an engineer is looking for various components. It will actually publish that information back to them, so they will start to use the standards and will no longer be able to actually use the not for use components. Okay. Any questions so far on this? Being a very nice audience and not bothering me. Okay. So here's some examples of using this sort of parts that has standardization. One of my customers that I dealt with, talking about the price variances for parts over the years. They had a total variance of the differences of what they paid for parts of like $6 million versus what they paid for another price, historical price. This is back in 2022. And that number was actually $22 million since 21, if you add it all up, or 2019. They had almost 17,000 common parts that were only purchased one time, but they were still tracking it in the system. And they had almost 10,000 parts where they only bought them 2 or 3 times since 2019. So analyzing all of this information, including the fact that they had 707 suppliers who had been vetted and contract negotiated with, et cetera, only once, just for a single given component part, which is an awful lot of overhead for the supplier community to manage 700 parts or 707 parts from 700 different suppliers, and only 2 or 3 orders were ever placed with almost 400 or almost 450 part suppliers. And in their case, they were actually migrating from Agile PLM to the 3D Experience platform on premise. And they looked at we did the analysis using the tool set of about 360,000 common off-the-shelf parts they had in their Agile system. And after this analysis, by saying, we haven't placed an order for this part since 2019 or 2022, we haven't really seen it in use in any engineering documents. We've got 16 of the exact same part with different part numbers. And they were able to reduce down the total number of parts that they needed to migrate instead of bringing in all their junk that they didn't need historically to maintain, and only needed 80,000, which is a 70% or 60% reduction in the overall parts that the supply chain was going to need to maintain and carry over. And once again, over a 1-year period after they were using the solution, there was a 30% reduction and over 30% reduction in the number of new part requests, even when they started with only 80,000 parts in the system. They had a 36% reduction in the number of requests that were coming in. Okay. So this would show you where we're establishing these standards, as I mentioned, to develop that. Oh, I'm going the wrong way. Here we go. So key takeaways here, right? By maximizing reuse in your existing parts library, you're reducing the amount of parts that are being proliferated. So the engineers will start to use these preferred parts and not the new parts that are in the system. This will help consolidate purchasing and inventory information, which allows them to create quantities greater or ordering larger amounts of fewer unique parts, because we're not creating a bunch of small orders for the same part, which enables them to also negotiate better terms for their long-term agreements, right? More parts with the preferred suppliers and reducing purchasing cost and parts availability by increasing the amount of parts that they order on a given purchase order, because they're not ordering 3 of the exact same kind of part under different part numbers that they've created internally. Okay. You look at that 25 to 30% part duplication environments and 15 to 20% just in production costs. So if you're creating, say, brackets or valve bodies, if you have the exact same valve body under 3 different part numbers and you're remilling it with different setups with the exact same setup, and you could make one single run at 3 times the volume, you're going to save a lot of setup money and costs in production, for example. And as we've seen across pretty much every industry that I work with, which is all of them pretty much, many of the customers are seeing between 2 and 4% of their total costs of goods sold as savings annually. And if you think about if it was even just 1%, a moderately sized company nowadays could have a common off-the-shelf, common cost of goods sold of, say, $900 million, could expect to see $9 million a year in savings, which would certainly offset, the return on investment for bringing in a solution like this, but 2, a bottom line savings for the organization that could be carried over as opening up more manufacturing opportunities, new areas to invest in the organization and the company, and maybe new product lines, et cetera. Okay. Any questions so far? All right, I have one final video here, I think, to present. This one's a little bit longer. This is from Olivier Colmard. He's the VP of Digital Transformation at Renault Systems Group, or Renault Group. I'm going to run through this. It's about 4 minutes, 3-4 minutes. I think we have time. Is that correct? Yeah, I think so. So I'd like to run through this. There we go.
So, in the last pillar, we manage collaboration and our strategy on data. Extended Virtual Twin, XVT. XVT is a tool based on NETVIBES technologies. Objective is to create a dashboard or cockpit called Data Perspective, mixing on one side data managed inside the 3D experience platform, including 3D digital twin, but also in other side, data coming from any legacy tools outside 3D experience, like purchasing, costing, quality, manufacturing, after sale, etc. I will show you a short video of one of our use cases. We have many others. We call it Digital War Room in Renault. A war room is a cross-company team looking for price reduction opportunities. So we start on the costing. We are in the costing team, and on the screen, data analytics are on the left, and as you can see also, PLM and digital mockup on the right. The objective of this tool is to track the gap between the real price and the target price given by the costing team. Here, I can focus on all the parts with the gap over 100%, for example. I can preview them inside the catalog. Here, I'm going to focus on this door hinge that I want to optimize. I can look at all the parts that belong the same categories. And finally, I decide to assign the collaborative task to his engineering colleague and to study a cheaper alternative technical solution. Just after, we are now at the engineering. I'm an engineer, I received the collaborative task. A tool in the platform called One Part will allow to propose parts with the similar 3D geometry. For example, in this range, get his attention before focusing on one 405% cheaper. I can verify that from a geometric point of view, and I can compare the two parts. Finally, the two parts are similar, or quite similar. Now remains the validation steps. That is to say, to verify that its new support the weight of the doors. I transmit a collaborative task to my colleague of the digital validation, the CAE engineer. And finally, the CAE engineer realizes a machine, and calculation of the effort. And it's okay, the part is validated, and the economy can be launched directly to the...
Okay, so you'll note here they were using one part, and that's because most of their CAD model data is still currently running inside of the 3D Experience platform on premise. However, the capability that you saw and the collaboration could occur as well through Part Supply Enterprise. So I want to kind of review a methodology for those of you who are looking to either find cost savings, potentially look at migration of your data into maybe the 3D Experience platform or some other platform area. And as I mentioned, you know, we kind of start with indexing that data across the silos, right? That was that edge agent in this particular case when we're talking about 3D Experience Part Supply. But it would be or also could be utilizing the one part application if you want to keep your data on premise. The being able to search and discover the parts, and literally as soon as you've indexed the data and brought it into a holistic view for the end users, your ROI happens right here. From there, we then can cluster using the AI and the machine learning algorithms, duplicated parts to then determine classifying the preferred and alternate parts. And then if you want, you could potentially start to use the 3D Experience platform and bring in ERP classification and other information into the platform and augment that with the classification against the current parts. But then you'd also want to start to identify the assemblies with the non-standard parts or the do not use parts. And based on that, go and clean up or fix all of those current existing subassemblies that are using those do not use parts with the now preferred or alternate parts. And here, your organization, you'd like initiate change management potentially in the 3D Experience platform, along with analytics, so you can see the burn down rate of all the assemblies. How quickly are you getting all of this done in preparation to actually then migrating that data in step 9 into your new environment? Okay, I have one more poll, I believe, right here. So I'm going to stop my share. And James, go ahead and pull.
Yep. All righty, let's open up the last one. Yeah, the last one is around what do you use for change management currently. Just wanted to get an idea of what other systems people are using out there. And it is a multi-select, since likely you're using a few different options. So we'll give this one a few more seconds. And Rob, we did have some questions come in, so I think we should have time here in a few minutes to review those. I can help facilitate that once we wrap up here. All right, looks like pretty typical, I would say, from my experience. A lot of Office, email, spreadsheet type of thing. SharePoint's pretty common as well. Of course, PLM has that capability, so that's good to see. And some ERP systems as well. All righty. Yeah, I think we'll probably wrap this one up. Yeah, thanks again for participating. That's some good feedback there.
Okay. Let's see.
Alrighty, yeah, I'll stop that one for now.
All right, so let me go ahead and reshare my screen. I think I have one more slide, but I'm not going to share the audio because I don't need to.
Yeah.
There we go. All right, so the key takeaways, as I mentioned, we're fairly source and CAD agnostic, multi-CAD search across all your existing data sources. It's a very quick ROI, happens early in the process versus a typical mass migration strategy, as I mentioned, where you're waiting for all the data to get moved into some new system before you can start to take advantage of that system. It helps reduce the costs and risks for your organization because we can coexist with your existing infrastructure things or tools and solutions during the period of the activity there versus a sort of rip and replace to wait until you've moved everything. And of course, increasing or accelerating the adoption because people are starting to get that activity, as you noticed from the collaboration that was going on inside of that demonstration from the example that Renault, this ability to collaborate together in a single holistic location to help keep everyone abreast and understanding where you are in the process of any of those kind of activities, etc. So I will end it with here, but we will answer these questions. So I think the first one was, are these floating licenses? No, these licenses from the end user standpoint are named user licenses. We do feel that from a ROI standpoint, the cost of even just reusing one component part will offset the cost of the license for one or two other users. So the very first time they use it, they'll offset the cost of other users. But if there's other questions along that line, we can discuss this in further. And the organization, GoEngineer can assist with helping your organization understand what the potential savings are to help build out an ROI based on the specific environments and the data that you have and what your requirements are, and potentially even get an idea of what percentage of potential duplications might exist against maybe a small subset of your data. Can you cluster by bulk pattern and ignore the overall shape? Yes, so that's a pretty good question. We can cluster based on lots of different kinds of information. I will try and bring up my UI again here. Where's this environment? Let me go back to the clustering tool here. If I was going to, let me go back to this one. In this compute area here, these are the abilities or what we can cluster on, and this is sort of out of the box with this particular data set. So it's what other kind of attributes are defined here. So if in your information it was bulk pattern or head type or other attribute information that exists in some of your other existing systems, they would get pulled into this clustering rule set. So I believe that would cover your question there. And as I say, this is ongoing or continuing to build based on whatever kind of data and attributes you're bringing into the system. Okay. If that doesn't answer it, please ask another question into that.
They had a second part to that one that just said, would it group a fabricated part and a machined part that had the same geometry?
Yes, it would, because if the geometry was identical, it's grouping it based off of that geometry. That's the shape similarity that you're seeing here. So if it was fabricated or machined or even purchased, it would show you that you're actually acquiring this from a supplier versus making these other two based on the machine typing or the design. So there could be different ways that a part gets created. It even could be a additive manufacturing kind of thing, a 3D printable part. And you can actually use things like bounding box and material dimensions against like the volume potential of the actual 3D printer to determine component parts that could potentially be built through additive manufacturing versus milling, etc. Hopefully that answered the question there as well. Is there any other functionality to highlight or notify you when your current design is using an obsolete part? Okay, so inside of this application, it will not let you know, when a current design is using an obsolete part, And if you're using this and you select the design and it's showing you the children, if one of the children is flagged as an obsolete part, it will show that it's an obsoleted part in that children's section. It's not designed to go back through and initially identify all of the parts that are, all the children or the obsoleted part against the child. But if you select the obsoleted part, you would then see all the parents that obsoleted part is a member of or belongs to. Hopefully that answers the question. So as you're actually searching at assembly level or a subassembly level, it would, and you look at the children of that part, it would flag it. We wanted to have it a little bit more direct, that could be actually an interesting enhancement request. I just realized it could be interesting when I select a given component part or assembly. It'd be nice to know if any of the children had been obsoleted or flagged to be obsoleted. That would be a pretty nice feature. I might suggest that as well. Good question. So 2D CAD, so it requires a solid CAD model. It does use the 3D for the shape similarity. I can tell you that 2D CAD drawings, we can provide for text search, not just on the key field area of the drawing, but against any call outs that are inside of that drawing. So if I'm doing a text search like I did with bracket, if there's a 2D drawing file, we can ingest that as a text document, just like we could PDF or a Word document, and it would show me all of those drawing files that had maybe that call out or that measurement. By the same token, the 2D drawing might be listed with the same part number as the CAD model, and we would be able to semantically reference from the CAD model selection what the 2D drawing file is and where it's located. So we could have that reference. It could be part of a BOM CSV file that's got or an Excel spreadsheet that's got that part in a BOM structure, etc. So hopefully that answers it.
There was another one, I think Gerald answered, basically just asking, they're using CATIA V5R32, which I think is V5-6 2022, and they just wanted to make sure that was supported.
Yes.
Right.
Yeah. From our standpoint, I believe that the add-in for CATIA will work, for CATIA V5 will work with older versions, even if the 3D experience environment is the 25X.
Yeah, the index it'll index the previous versions of CAD data. It's as well, right? I think is an important point.
Absolutely.
So if people are using multiple versions of V5, it can still index the older versions of
that is correct. We can actually index CATIA V4 as well. So
right.
If anybody who's still got old CATIA V4 in their stacks of stuff, we can index that data. And if anybody's interested, James, they could reach out through your organization, and we can provide them a list of the supported CAD versions for each of CAD model types, and what's the current supportable version available.
Exactly. And there was, that's a good point. There was another more of a in the chat. Someone had mentioned that showing changes between revisions for solids and drawings would be a great add. I will say I do sort of know the answer to this one. So one part or part supply doesn't actually show comparisons, but the 3DX platform does have tools that you can overlay drawings to see 2D. So what I guess the scenario would be is you could find the duplicates using these NETVIBES tools, the part supply and the one part tools. Then in the platform, you can, now that you found those two, you can then use the compare tools to actually do an overlay of the 3D geometry, right? And it'll show you the differences. I think Rob has a video of that. And it also does work.
It's actually in the Renault video, James.
Yeah, and it works on 2D as well. So
yeah, and that would work.
So that is an option. Yeah, so that's an option. If again, any of these questions, if you want some follow-up, want us to demo how that works, any of that stuff, just get in touch with your local representative, and we can certainly follow up on that. There was one last one that came through. I can push it to the Q&A. It'll be at the let me see where it went. It's at the top of the list of the Q&A, I think, Rob, about text features. Do they only work with clean, searchable? Yeah, you got it.
Yes, the scanned PDFs are basically just an image file. So the text search won't work against a scanned PDF. The methodology that a lot of our customers are using, because one, we don't offer what's called optical character recognition tools automatically within the product, but you can analyze using, OCR or optical character recognition tools that are in the market for ones that seem to provide the best text result sets from your scanned PDFs, and use that to create a text document that we could link together the two and then match the PDF, the scanned document to the text portion of it. If you're using our on-prem version, that activity can actually be also run inside of its typical processing methodology, which I believe would also work with the Edge Agent functionality, but I haven't ever tested that. I can tell you that one of our customers has, tons of scanned PDF documents. A couple of different examples if we have enough time here. I have 1 minute. All right. So in one case, a customer was being sued by DuPont because they used the word Teflon without detailing out the trademarks that DuPont had. They had millions of documents going back to the 40s in a file system. They used our technology to scan all of those files, including their PDFs, using the third-party OCR tool as a part of it. And they were able to identify the 47 out of 1.8 million documents in a short period of time, like a couple of days, of all of the PDFs or any document that they had published that did not list the trademark notification around Teflon for DuPont or associated to DuPont. So then when they went to court, they proved exactly, how many documents it was and how they actually achieved it. It was a pretty quick win for them in that case because it was a limited amount of documents rather than spending how much they would cost to have, offshoring all this document reading to have somebody go and search every single document or read through it. Another example is an aircraft designer, OEM. They have scanned in every one of their 2D drawing files going back into very first versions of their commercial aircraft, and make those PDFs are made available to the services people so that they can actually look up that particular tail number or that particular product or customer's product and identify given components even in the old 2D drawings before they even went to 3D CAD designs. And that's available at the field engineer right at the maintenance areas. So just another example for you.
Cool, thanks, Rob. I'm not seeing any other questions or comments. I did want to just make one more clarifying point, I guess, is that Rob showed the part supply, and a lot of that was integrated with the 3D Experience platform. So if you move to 3DX platform or already have it, that can be used and added. But I do know several of you that are on don't have 3DX, may never intend to move to 3DX. So the same functionality, right? The similar searching and replacing and all that kind of stuff is available in that standalone one-part solution. So I know Rob mentioned all that, but just to kind of clarify for anyone who's watching this. And then, yeah, we did answer, Adam, that question, I believe, on the cluster and bolt pattern and overall shape. Rob did go through that.
I did go through that.
But any follow-ups, if you didn't hear that, you want to get more information on that, feel free to reach out to us. I think Yeah, we're a little over time. Thanks everyone for staying. I see there's quite a few still on, but yeah, we appreciate everyone joining and all the participation, questions, polling, all that stuff. Like we've said, feel free to reach out to your local GoE rep for any other questions. Rob and I both be happy to follow up with demos or videos or whatever would be helpful for you. And I think this is all recorded too, so you should be able to watch a replay of this if you want to kind of review everything that we went through, because there was a lot of stuff in there. So
Yeah.
Alrighty, perfect. Okay.
Okay.
Yeah,
Well,
we can wrap it up.
Yep. Thank you, everyone, for your time. Appreciate your getting involved and reaching out to us, and really appreciate it. And so, thank you so much. Take care, everyone. Have a pleasant
Thanks,
week.
everyone.